All right, so we're going to go ahead and get started with properties of limits. So, properties of limits, they really come down to just a huge box of rules that you can use. I'll be honest with you, a lot of these things you probably could figure out on your own, but we have them all here just in case, and we want to define them as things that we can use all the time, and we will continue to use them throughout calculus. So, for number one, it talks about the limit as x approaches c of k is equal to k. What that means is k would just be a number, so we would have basically a horizontal line at whatever number you state. So let's say of 2, it would ask you what is the limit as x approaches, let's say 7. So the limit as x approaches 7 of 2. So since the function 2 is just a horizontal line, it'll always approach 2, and that's why the answer is k. And then we have the identity rule. It says the limit as x approaches c of x is c. And then you can read the rest of the rules here. So go ahead and pause and read through them. They should be pretty self-explanatory, except for maybe the composite function. Go ahead and read. Go ahead and press pause and read through them. We're going to practice with them. All right, so it says example 1, use properties of limits to find the following limits. So when we go through and do this, we're going to make sure that we're rewriting the entire time. So you want to rewrite using the rules that we just did, and you're going to need to write it all out every time, okay? So you have to go through and write exactly what rule you're using every time you use it. Give me just one. Okay. Now, what we're going to do is this says the limit as x approaches 3 from the right side of f of x plus g of x. If you remember our rules from above on your page, it says that you can actually separate them. So you would say the limit as x approaches 3 from the right of f of x plus the limit as x approaches 3 from the right of g of x. Yes, you must use this step. Yes, you must rewrite it just like this. Now you can go through and plug in the numbers. So 3 from the right for f, 3 from the right is going to be 6, plus 3 from the right for g is 8. 6 plus 8 is 14, and the answer is 14. Okay? Yes, you have to show this step. It is an absolute must. Please drop the limit notation when you plug in the numbers, just as before. Okay? This is supposed to be a step. Okay. So for letter B, we're going to do the same exact idea, except now we have the coefficient rule. The coefficient rule says that you can put it out front of your limit. So it's going to go 3 limit as x approaches 5 of f of x minus 2 times the limit as x approaches 5 of g of x. And then we're just going to go through and plug in the numbers. So 3 times, as we approach 5, it's going to be 2. And 2 times, as x approaches 5 of g of x, we have 4. So then we have 6 minus 8, which is negative 2. Okay? Now we're going to do the same exact thing for letter C, except it's talking about negative 5 from the left. So the limit as x approaches negative 5 from the left of f of x minus the limit as x approaches negative 5 from the left of g of x. This is all just rewriting, okay? You must do every single first step that we've written here in the exact notation that we're writing it if you'd like to receive full credit on any assessments that you do. Now we're just going to plug it in. Alright, now we're going to move on to the next one. So the next one is basically the same exact idea, you're just rewriting. So it's all just about rewriting it in the correct format. So I'm going to show this, I'm going to pause it and show the 3 at the same time. Alright, Now they've all been rewritten and we're ready to go ahead and plug in the numbers. So remember that 3 is the coefficient that gets to go out front, so that's why 3 limit as x approaches negative 7 of f of x. We're going to go through and just plug it in. So 3 times negative 7 looks like 5 over the limit as x approaches negative 7 of g of x is 3. So our answer should be 5. Okay? Now, letter E is all about doing the order of operations correctly, or maybe not correctly, but making sure that you don't distribute the 4 twice. Okay? So the limit as x approaches 3 of f of x is 6 times the limit as x approaches 3 of g of x. Oh, do you guys see that for 3, it looks like we're coming from different sides or different places for different sides. So this is actually does not exist. Lucky for us, these are going to become our favorite ones, because anything times does not exist, does not exist. Okay? So you don't even have to really think about that anymore, it just does not exist. So now we're going to do the limit as x approaches negative 3, and then square it. So as f of x approaches negative 3, we're at negative 6, and we're going to square it, which gets us 36. Alright? Now we'll move on to the next one. I'm going to go ahead and rewrite just like I just did so far. Alright, now that we have them all rewritten, we're just going to go through and evaluate them. So remember, the square root can be taken outside the limit. Sorry about that. There's a dog. Okay, so now we're going to go through and we're going to take the square root. We're going to do 8. And then the limit as x approaches square of g of x seems to be 5, which is the square root of 40. And we should know how to simplify that pretty quickly. That would be 2 square root 10. Alright, now we're going to go through and do the same exact thing over again. So this time we add our limits, and we need to make sure to put the limit definition in front of each of them. So we have negative 6 plus does not exist, which means that this does not exist. Okay, now for I, we're going to do the same exact thing. Limit as x approaches 6 of f of x is 0 over the limit as x approaches 6 of g of x is 5. So my answer is 0. Okay? Now it's asking, it says find the limits. This is actually even easier because it gives you the limits. So you don't even have to look at your graph. Now you just get to rewrite and then plug in these exact numbers. So I'm going to rewrite them first. You go ahead and rewrite them as well. So I'm going to pause. Alright, and now we're ready to go to just plug in the numbers. So it's even easier than our first one. Except we don't even have to look at a graph. So we have 3, they want the limit of h of x, which is right here, 4, minus 2, g of x, because it's negative 2. So we have 12 plus 4. And then we have the square root of 16, which is just 4. Alright, now we're going to do the same exact thing for letter B by just plugging in. It says limit as x approaches c of f of x is 3. So this becomes just 3 times 5 times g of x is negative 2. So we get negative 30. Okay? So I'm going to go ahead and pause and rewrite. Alright, now I'm sure a lot of you are saying, holy cow, we have to write all of this out every single time. And the answer is yes, you do. You absolutely must show this stuff, especially in letter D. It has to be shown in order to get full credit on the quiz. So, for letter C, this is talking about the constant rule again. So remember, this constant rule just says that this one is 7 minus, and then we want the limit as x approaches c of g of x, which is negative 2. And then we want to square it. That's 9 squared, which is 81. Alright, Now we're going to do the same thing here, although it looks slightly more complicated, but it's really not. F of x is 3, 3 times h of x, and then h of x minus g of x plus 12 is 18 over 6, which is just 3. Okay? Now we'll move on to our next one. Alright, so I will tell you that these two, for letter E and letter F, you want to make sure that you're doing the order of operations correctly. So this one says that we're going to do h times the sum of f of x plus 6. So rewrite it, and then we'll talk about what order you need to be. Alright, so now we have them rewritten. So for letter E, we're going to do h of x, the limit for h of x is 4 times, and then these brackets are kind of important here so that we know that we're going to do the addition first here. So f of x is 3. The limit as x approaches c of 6 is just a constant, so it's just 6. So we have to do 4 times 9, which is 36. Okay? Now we're going to do the same sort of thing over here. We want the limit for f of x, and we want to square it, so that's going to be 3. And then we're going to square it over constant function, so 4 minus, and then g of x is negative 2, so minus negative 2. We have 9 over 6, which is 3 over 2. Okay? Now, I will tell you, I had kids ask about this part here where you have your constant. Do I have to put the limit of the constant? Because it's just 4. The answer is yes. You must put it. Okay? So now this is the same sort of thing. I like to think about this kind of like doing expanding logs. So you're just going to rewrite the whole thing, and then you're going to get to plug everything in. Okay? So I'm going to pause because it's kind of a long one. Alright, so it's a very long one, but now we can go through and actually plug things in. So 2 times the limit for f of x is 2 times 8. Times the limit of g of x is negative 4. Minus the cube root of 8. I guess that's going to be 4. Okay, and then plus 2 times g of x, which is negative 4, squared. Okay, so this one's going to get us negative 64 minus 2 plus 2 times 16. Okay, so that's negative 66 plus 32, which is negative 34. Okay, sounds good. We'll move on. Okay, so now it says find the limits of the following composite function. So if you go back to the composite rule, it tells you that when you have the limit of a composite function, you just take f of the limit of the interior function. So you take the outside function and it stays itself, and you take the limit of the inside function. So you only end up actually taking the limit exactly once. So the limit as x approaches 2 of g of x is we're going to actually find that out. So over here I'm going to do the limit as x approaches 2 of g of x, and I'm going to find out what that is. Okay, so that means I can actually directly substitute here. Remember, drop the limit notation when you plug in. And I'm going to do f of negative 4. Okay, so f of negative 4 equals negative 4 cubed minus negative 4 squared plus 4 times negative 4, holy cow, minus 1. That's going to be negative 64 minus 16 minus 16 minus 1. Negative 64 minus 33 is negative 97. Perfect. Now we're going to do it again. So for letter B, it's the same exact idea, except we're going to keep the outer function. going to do the limit of the inner function. Okay. Now we're going to find the limit of the inner function. Limit of x equals 2 of f of x, and you get to just plug in 2 cubed minus 2 squared plus 4 times 2 minus 1. So we have 8 minus 4 plus 8 minus 1. Okay? That's 16 minus 5, that will be 11. So we're going to do g of 11. G of 11 equals negative 2 times 11 equals negative 22. Wonderful. Okay? Now what's asking you to do is like with graphs, but it's the exact same thing. So we're going to rewrite f of the limit of g of x. Okay? So for g of x, oops, one more step. For g of x, the limit as g of x approaches 3 is 1. We want f of 1. You can just look at the graph. F of 1 looks like right here. That's negative 2. Perfect. Now we're going to do the exact same thing. Outer space, limit as x approaches negative 1 of f of x. So as I approach negative 1, looks like I'm down at negative 6. G of negative 6 equals, oh, we can't get there, but we can continue. So down, there, this is negative 5. So we can go 2 more down from there. 5, so negative 7. And you should be able to continue that on without too much trouble. Okay? And now we'll continue with the same question. So f of the limit of g of x as x approaches 1. As x approaches 1, it looks like we have f of the limit as g approaches 1 is does not exist. Now this is does not exist. Alright, and final problem, we're going to do g of the limit as x approaches negative 3 of f of x. Alright, so as we approach negative 3 for f of x, that's negative 6. So g of negative 6, which we already did, is negative 7. Alright, hope this is helpful.